Hello everyone. Today I am going to discuss the fifth problem of AtCoder Beginner Contest 289, which is swap places. So what is the problem? We are given a simple undirected graph with n vertices and m edges. So each vertex of the graph could be either 0 or 1. Now let's say there is a graph 1, 2, 3 and 4, and the vertices are marked 0 or 1, either 0 or 1, 0 or 1. And now Takahashi is present at first index and Aoki is present at the last index, nth index. Now in each move Takahashi will move to one of its adjacent members, and Aoki will move to one of its adjacent nodes. Okay, now the jump would be in such a way that the landing node of Aoki, the number in the landing node of Aoki is different from the number in the landing node of Takahashi. So here Aoki can jump to 2 and Takahashi can jump to 3 because 1 is not equal to 0. Now the second move will be Takahashi will move to 2 and Aoki will move to 3. And the third move will be Takahashi will move to 1 and Aoki will move to 1 and Takahashi will move to 4. So the our final achievement will be if Takahashi moves to n and Aoki will moves to 1. So initial configuration is 1n and we have to make the moves in such a way that Takahashi moves to n and Aoki moves to 1. So this problem is not very hard. The implementation or the thinking process is not very hard. The main problem is to explain yourself the complexity. So let's say when we are in a competitive programming contest, we always think about different brute force solution, and after seeing the constants we might think that this solution will not pass because we just see the complexity in each of the test case, or you can say in each of the case, like there are q queries and we are seeing that our complexity of each query is order of n, so we just assume that our overall time complexity is order of q into n. But there is a concept of amortized analysis. So in amortized analysis, for all the test cases or for all the queries, we just try to integrate like all the the overall time complexity. Like if you want to find like makes, like the finding makes algorithm, there is a nested for loop. If you look at the makes finding algorithm, minimum excludent, you can find it in GFG. There are two loops, but you might think that the complexity is order of n squared because the two loops are involved. But when you notice carefully, you will find that the amortized complexity of the entire algorithm is order of n. So here that concept is used. So without further delay, let's jump into the observation first. So I hope you got the amortized analysis part because this will be required in the latter part of the video. So let's jump into the observations. Okay, so what is the brute force solution you can think of? You can think of some kind of BFS, like the breadth first search, because when we want to find the minimum number of moves, we will just find it by breadth first search. Okay, so what is the breadth first search? I think you all might observe that if we consider the Takahashi node and Aoki node in a tuple or in a pair, like the Takahashi node and Aoki node. So initially Takahashi node is 1 and Aoki node is n. So from this 1 comma n node, so we can consider 1 comma n as a node. So in from 1 comma n we can move to I comma j. So we from 1 comma n we can move to I comma j. There are two conditions here. The first condition is 1 is adjacent to I and n is adjacent to j, and the second condition is color of I should not be equals to color of j. So these are the two conditions. Now if we do some kind of BFS with considering this as a node, and we just want to find all I comma j and do a BFS on that, you might think the time complexity will be like for 1 comma n to I comma j, the time complexity is order of n square, and for like the order of n square number of nodes, because every I comma j node is required, and for each node, let's say we are at some node I comma j, now we have to find k comma l adjacent nodes. Okay, so this is, you might think the overall complexity is order of n square into order of n square, because we are finding I comma j and again we are iterating on k comma l. So the first is for I comma j, and the second is or the adjacent of for all k adjacent to I, and for all l adjacent to j we will just move to like we will move to f of k comma l. I hope you got it. So this is our main thing. Like for all I comma j we are moving to k comma l, which is k is adjacent to I and l is adjacent to j. So you might think the order of time complexity is order of n to the power 4, but that is not right. So let's look at what is the overall amortized complexity of this. So the amortized complexity for each test case is so we are just iterating on each of the node. So what are the number of nodes adjacent to I? The number of nodes adjacent to I is, let's say, degree of I, okay. And the what is the number of nodes adjacent to j? The number of nodes adjacent to j is, let's say, degree of j. So we have to find the summation of order of the total time complexity is order of summation of di into dj, okay. Now summation of di into dj, so summation ij di into di into dj. So let's take di out, okay. So let's take di out. Now we are taking di out, so we are taking I hope you know that. Now this is summation of di into summation of dj. Now what is summation of dj? Summation of dj is nothing but m is the number of edges. So this is I di into m. Now what is summation of di? The summation of di is again n, so m into summation of di. So the overall time complexity is nothing but m squared. Now the overall time complexity for each test case is order of m square. Now there comes another interesting part. This is quite easy because n is m square and m is minimum of n squared comma 2000, so m is 2000 also. So for each test case time complexity is order of 2000 square. Now here another amortized part, the sum of m over all test cases is 2000. So the overall time complexity of all the test cases is nothing but order of m square, order of 2000 square. So this is quite straightforward. I hope you understood what I am saying. Now let's jump onto the code. So let's go. This is the code, okay. So this is quite straightforward code. So here I am just taking the input, the color of I 0 or 1. So this part is straightforward. I am building a tree. So this check you can do, that if the color of the first node and the last node is not same, this is not required at all, because if we delete this part, this will also be right answer, okay. So this is straightforward BFS. So if we will just break if the Takahashi node is n and the Aoki node is 1, then we just break. Our answer will be the u2. So the queue will contain three numbers. The first one is Takahashi node, second one is Aoki node, and the third one is the total number of moves. So first one will be, let's say this is moves. So this is move. So the first parameter will be Takahashi node is 1, Aoki node is n, and the distance is 0, okay. So we are just putting 1 comma n comma 0 here, and we are just marking this also, the visited of 1 comma n, this will be 1. I don't know why I have marked this as 2. We can mark it as 1 also. So yeah, now we are just iterating over all the adjacent node of Takahashi node and all the adjacent node of Aoki node, and if the color of the two nodes are not equal, and this node like the we are considering I comma j as a node. I hope you know that because I have explained earlier. So we are just taking that visitor of j comma k is 0, then we are marking it as 1 and pushing j comma k comma u2 plus 1. U2 is the move. So if we want to move from I comma j to k comma l, so the move will increment by 1. So at the end we are just clearing the queue and printing it as answer. I hope you understand all the time complexity related part and all the code part. If you have any doubt in any part of the video, please write in the comment section. If you find this video helpful, please like the video and subscribe to my channel. Thank you.